Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a comparison between expert modeler feature, which is present in IBM SPSS, and a customized model, which I'll be building. We'll be making a comparison between the expert modeler feature versus the customized model. We will look at which model performs better. Even before I proceed to demonstrate the comparison between expert modeler feature in IBM SPSS and the customized model, may I request you to subscribe to my channel, also like and share my videos. Let me begin by talking about the time series data. For those of you who are very new to what is called as time series data, you may always have this question at the back of your mind as to what exactly is time series analysis. Time series data is also called as timestamp data. This is the data which is arranged as per chronological order. The chronology may be day-wise or week-wise or monthly, yearly, or quarterly. Time series data is widely used in the financial sector. May it be stock price prediction, or may it be the prediction of important the prediction of important commodities like rice, wheat, vegetables, so on and so forth. For any of these problems, you can go ahead and use the time series analysis option. In this video, I'll be using a very interesting data set, which is called as the WPI, or the wholesale price index of rice, for 9 years. This data I have picked up from the Ministry of Commerce website. So this is absolutely real-time data. It is not a fictitious data. What I intend to do is use 9 years of data to generate prediction for the 10th year, and we'll be making a comparison between the actual and the predicted for the 10th year. Let me show you the data set on which I will be building the model. I can go to the File menu. By the way, this is the IBM SPSS interface that you're seeing in your screen. Let's click on the File menu. You have the option which is called as recently used data. Here, the second item from the top, which is called as training data V1, I'll be using this particular data to generate predictions. The moment I click on OK, you can see here, this is the data which pops up. There are 5 columns in this particular data set: serial number, date, year, month, and the last variable, which represents the WPI, or the wholesale price index of rice. You can see here, for the month of January 2001, the wholesale price index of rice in India was 164.8. Then in the next month, that is February 2001, the wholesale price index of rice reduced to 163. Further, when you look at March data, the WPI of rice increased from 163 to 165. So this is the same trend that we go on to see. Let me show you the last record. You can see here, the last record stops at April 2009. I don't have any data post 2009. I've got blank records. What we are going to do is we are going to build our model using information till April 2009. We will be generating the prediction till April 2010. Once we generate the predictions for the next year, we will be comparing the actual versus the predicted and arriving at suitable inferences. Now, one question that might pop up in your mind is, where is the actual data post April 2009? I have saved this particular data in a separate file. Let me show you that particular file as well. Let me go to the File menu. Here you have the option called as recently used data. I've got test V2. You can see here, test V2. Let me click on this particular option. Here again, we have the same 5 variables: serial number, date, year, month, and WPI of rice. There's one difference, and that difference is the starting date here is January 2001, and the last record here is April 2010. which means I've got one additional year of data. So this is the data which I have from April 2009 onwards, that is May 2009, June, July. This is the additional 1 year of data that I have. And this value that you see to the extreme right side represents the actual WPI of rise post April 2009, 233.8, 235.8, 237, so on and so forth. So we'll be making a prediction. We'll be comparing the actual versus the prediction. Let me begin by going to the training data set. So this is the training data set that I have. The first thing that you need to do when you're building any time series data to examine if there is any trend, to examine if there is any seasonality and other time components in the data. Now, to examine whether or not there is trend, whether or not there is seasonality, there's a very simple technique which is called as the time series plot. You can also do this in Excel if you're comfortable with Excel. First things first, let's go ahead and study whether there is a trend in the wholesale price index of rise for the last 9 years. How do we examine the trend? Let me click on the Analyze menu. Here, there's an option which is called as forecasting. This is the option which is called as forecasting. Here, there's an item which is called as sequence charts. You can click on this particular feature which is called as sequence charts. This will open up a new dialog box which is called as the sequence charts dialog box. In the left hand side, you have 5 variables. To the right hand side, you have a box under the variable section. You also have a time axis labels. Under the variable sections, I will be choosing rise. When it comes to time axis labels, I will be choosing date time format. Once you have chosen these 2 variables, you are all set to click on the OK button. Now, this is the data window. The output will not be produced in the data window. You can go ahead and look at the output in the output window. So this is the output window that we have. And in this output window, you can see this is the time series plot that we have. What do we have in the x-axis? We have January 2001. The next quarter begins at May, followed by September, all the way up to January 2009. In the y-axis, we are taking the wholesale price index of rise. The minimum WPI of rise is 160 and the maximum WPI of rise is 240. There's a very interesting trend that we observe. From January 2001 all the way up to May 2006, we don't see a clear upward trend. Yes, there is quite a bit of an increase, but it is not a sharp increase. It is within control. It is well within a range. But the graph actually begins to take off post 2006. You can see here, post May 2006, you can see there is an increase in the WPI of rise. Clearly, when you look at this from an overall perspective, there is a global upward trend. And this trend becomes more conspicuous post May 2006. Here and there, you may see some bit of a spike here, but again, there is no strong evidence to suggest a spike in any specific quarter. Now, since there is trend in this data, we need to be careful. By the way, trend is the enemy of stationarity. In time series analysis, for most of the models, the underlying statistical assumption is that the data should be stationary. The data has to be stationary. Non-stationary series becomes very, very difficult to model. Unless you stationarize the non-stationary data, you cannot go ahead and build a time series model. Trend is the enemy of stationarity. So we will have to stationarize the series as well. Now, with this understanding, let me go back to the data. You can see here, this is the training data that I have. In this training data, I'm going to build the model. The first model that I'll be building is through expert modeler feature in IBM SPSS. I can go to Analyze menu. In the Analyze menu, you have the forecasting option. Here, the second item from the top is Create Traditional Models. Let me click on the second item from the top. This will generate a new dialog box, which is called as Time Series Modeler. There are 4 variables. Let me choose the 4th variable and push it into the dependent list. So this is the variable that I will be using to forecast well ahead of time. The default option is Expert Modeler feature, which simply means that SPSS itself will identify the best fitting model for your data. We don't have to manually experiment and see which of the time series models is the best one, because experimenting with the existing models is a time-consuming process. You have many different time series models like exponential smoothing and ARIMA models. Exponential smoothing is further split up as non-seasonal exponential smoothing models and seasonal exponential smoothing models. We have a wide array of models like simple model, Holt's model, Brown's model, damped model, Winters additive, Winters multiplicative model. Further, we have different parameters for ARIMA as well. So this becomes a bit difficult when you have a very, very complex model, and hence SPSS is trying to help us by suggesting to us which is the best model according to SPSS. At the back end, at the background rather, you can see the date begins at 2001. And when you scroll down, the last record here is April 2009. Now, we can go to the save option. We can save the predicted value, the LCL, as well as the UCL value. The lower confidence limit as well as the upper confidence limit will be generated along with the predicted values. The last button here is what is called as the options button. When you click on the options button, the second option from the top is what is called as first case after the end of estimation period through a specified date. I repeat, first case after the end of estimation through a specified date. Here, I can say, please generate the prediction till 2010 for the 4th month. That is from April till April 2009, all the way up to April 2010, I'm requesting SPSS to give me the results. Once you have done this, you're all set to generate the model. The first model, remember, will be built based on the expert modeler feature. Let me go ahead and click on the OK button here. Now, we are in the output window of SPSS. Please observe the first table. This is the model description table. SPSS says 110000 ARIMA model is the best model. These are the non-seasonal parameters, and 000 are the seasonal parameters. Automatically, SPSS has identified ARIMA with the parameters of 110 as the best fitting model for the prediction of the price of rice. Now, we do not know for sure whether this is really a champion model or not. We will have to examine this further. Please observe the model summary statistic. You're getting a whole lot of summary statistics to tell us whether this model is a good model or a poor model. There are different fit index like stationary R-square. We also have R-square. Remember, when you're doing linear regression, we get only R-square, which is the coefficient of determination. Here, we are also getting what is called as stationary R-squared because we are performing time series analysis. Then we have what is called as Ramsey or root mean square error. Further, we have MAPE or mean absolute percentage error. You also have max APE or maximum absolute percentage error. Then you have mean absolute error, maximum absolute error, and normalized BIC. This is the mean value of each of these fit measures. Primarily, what we do is we look at the stationary R squared value. Higher, the better. The same argument holds good for R squared as well. Higher values of R square indicates the model fits the data well. Here, when you look at the Ramsey value or the root mean square error, the Ramsey value should be low. How low? Lower the value, better it is. People also prefer to look at what is called as MAPE or mean absolute percentage error. Typically, if the mean absolute percentage error is less than 5%, it's a good indication. Let me further scroll down here. This is the third table that we are looking at. Here, we are getting the stationary R square value as 0.07. This is the stationary R squared value for rise. Then you have what is called as a Young box statistic. The Young box statistic is a model fit index. It tells you whether the ARIMA 110 model fits the data well or not. The value of the Young box statistic is 8.6 with a degrees of freedom of 17. Here, please observe that the significance level is 0.951. The significance level or the p-value is greater than 0.05. And since it is greater than 0.05, it is an indication that the model fits the data well. So we can be happy that expert modeler feature has done a good job in identifying the best fitting model for our data. Let me now scroll down and look at what is happening with the prediction. As you can clearly see here, we have data from January 2001 to May 2009. This is the training data. We have obtained the prediction data after May 2009. Therefore, there's a vertical line. This vertical line is the boundary which separates actual data and the predicted data. The blue line here represents the forecasted value over and above 2009. There's a very disturbing sign here, and that disturbing sign is you can clearly see that post January 2006, the red line or the actual line is on an increasing trend. So common sense would tell us that this trend is likely to continue post 2009 as well. Unfortunately, when you examine the forecasted value, the trend is actually not picked up appropriately. The forecasted value just says that after May 2009, the predicted rise price will be constant. It will be the same, which is a bit hard to believe. And hence, this is an important message and a learning for us that expert modeler, though it generates prediction, it need not be considered as the gospel truth. So we need to be slightly careful about taking this at face value. Let's examine this further though. How do we examine this further? To examine and investigate the performance of the model post May 2009, I'll go back to my data. This is the training data. You can see here earlier I had only 5 variables. Now I've got 3 additional columns, namely predicted rise, LCL as well as UCL. This is the date column. Let's look at the last record here. It is April 2010. In fact, when you look at the actual wholesale price index of rice post April 2009, you can see here post April 2009, there are nothing but blank cases here. We do not have the actual WPI of rice post 2009. But we have successfully made a forecast 1 year ahead of April 2009. You can see here, these are the forecasted values 1 year henceforth, correct? We have the forecasted values as well as the LCL and the UCL. What I intend to do now is select the predicted rise, right click on this, use the copy option. I'm just going to copy this option. Let me make sure that I've done this right. Right click again and copy. Let me now click on the SPSS button. Here in the SPSS icon, I'll be moving to the second file, which is the test file. Here, you already have the actual price of rise till April 2010. So what I'm going to do now is I'm going to paste the predicted WPI of rise next to the actual data. So you can see here, this is the actual price of rise, and this is the predicted wholesale price index of rise. What we are going to do is we are going to make a comparison between the actual and the prediction. How do we do this? Here again, the sequence chart helps us. Let me now go to the Analyze menu. In the Analyze menu, I have the forecasting option. Once I enter this, I can go to Sequence Charts. This will open up a dialog box which is called as the Sequence Charts dialog box. You have the variables box here. You can choose the actual wholesale price index of rise as well as the predicted values from rise. You have the time axis labels. In this particular option, I'm going to choose the date variable. I've got actual and the predicted, and in the x-axis, I'm going to use date variable. You can provide additional customization as well by going to either the format option or the timelines option. Let me go to the timelines button. Here, I want SPSS to draw a line in the year 2009, and month would be 4, because I want a boundary which separates the actual data to the out of time prediction that we have made. Let me click on continue and then say OK. Let me now go to the output window of SPSS. Now here you can see the performance of the model. Please observe the legend. The blue line represents rise. There is the actual price of rise, and the red line indicates the predicted value of rise. From Jan 2001 all the way up to May 2009, when you look at the blue line and the red line, they're almost intertwined with each other. They're very, very close to each other. There is no gap at all between the actual and the predicted, which means that for the training data till May 2009, the prediction accuracy is very high. But we are not interested in the prediction quality till May 2009. We are interested in the quality of the prediction out or after May 2009, because that is the future data. How is the model behaving post 2009? When you look at the blue line here, clearly the blue line is on a upward trend. It is demonstrating an upward trend. Please observe the red line. The red line is moving to the right. It is nowhere close to the blue line, indicating that the expert modeler has done a very poor job of making predictions post 2009, because there's a huge gap between actual and predicted for the two variables. Now, this is a clear sign that if we were to implement this model for future, we will not be doing justice. Our predictions are totally wrong. Question is there another way in which we can improve the quality of prediction? To improve the quality of prediction, what we will be doing now as stage 2 is to build our own customized model. This customized model I'll be building on the training data set. Let me click on IBM SPSS. This is the training data that we have. We have the predicted LCL as well as the UCL columns. Let me now go to the Analyze menu. Come to the forecasting option. The second, my apologies, forecasting. The second item from the top here is create traditional models. I repeat, create traditional models. Once I click on this particular option, create traditional models, here you can see dependent variable. I'll not be making any change as far as the dependent variable is concerned. But observe the method. The earlier method that we used was expert modeler. I can click on the drop-down menu. Instead of expert modeler, I will be building my own customized model. You can go ahead and build either exponential smoothing model or ARIMA model. I will be choosing a ARIMA model. These are the parameters of ARIMA model. AR stands for autoregressive component. I stands for integration, or the degree of differencing that you're basically taking to stationarize the series. And the last component is moving average. So you have 0, 0, 0. These are the non-seasonal parameters. In the second parenthesis, again, you have 0, 0, 0, which are the seasonal parameters. You are free to change these parameters by clicking on the criteria button. So I've just clicked on the criteria button. You can see here, autoregressive component is denoted by P, differencing component is denoted by D, and the moving average component is denoted by Q. Now, what the expert modeler feature has done is, it has earlier identified 1, 1, 0 as the best model. I have experimented with different combinations of P, D, Q, and based on my research, I've come to the conclusion that for this data, 113 would be a better model. Therefore, under the seasonal section, I'll be specifying 113. Now, you may be asking as to how did I arrive at this magic number? There are two ways of arriving at this number. This is an experimental process. You have to change the hyperparameters here. You have to give different combinations. Look at the stationary R square. Let's say in the first iteration, you try 111, observe the stationary R square. In the second iteration, you can look at 112, then experiment with 113, 213, 123, 333, 331. You can give different combinations and look at which is producing the highest value of R square. If you want to save time, people also recommend that you use ACF and the PACF plot. By ACF, I mean autocorrelation function plot, and by PACF, we mean partial autocorrelation function plot. You can use any of these plots to specify the parameters here. But I want to keep it simple here and go with the option of 113, ARIMA 113 model for the prediction of the price of rice. Let me now click on continue and then hit the OK button. You can see here, these are the 3 columns for expert modeler predictions. If I scroll to the right side, you can see I'm getting 3 new columns for ARIMA 113. So these are the predictions that we've been able to make based on ARIMA. Let me go to the output window to just check the quality of predictions. You can see here, the second model which I've built now is ARIMA 000113. If you look at the earlier model, let me go to the model description button here. The earlier model which expert modeler is suggesting was 110000, but we observed that this is not a good model, and hence we went on to build our own customized model of 113. You can look at some of the fit statistics like stationary R square, and Ramsey. The Ramsey value is very important here. It is 7.8. If you look at the MAPE value here, it is 3.0. MAPE is a very, very important statistic, and we can put a lot of faith in MAPE. A value of MAPE which is less than 5 is a good model. It indicates a good model. Let me show you the MAPE value for what expert modeler generated by clicking on model description. the MAPE value was 0.697. So the MAPE was lower in the expert modeler, indicating that the model built by expert modeler was better. But let's examine with our own prediction. Though the MAPE is not as good as what expert modeler suggested, let's still go ahead and look at some of the other statistics. Now, interestingly, what you see here is the young box statistic. The young box statistic now is 274.416, and the significance level is 0.000, indicating that the p-value is less than 0.05. Since the p-value is less than 0.05, it indicates that the model that we have suggested does not fit the data well. It does not fit the data well. So though statistics is loaded against the model that we have built, I would still look at the predictions. Please observe the predictions here. The red line, as you have observed earlier, till May 2009, from Jan to May is the actual data, and the blue line represents the prediction. Now, the predictions, if you ask me, are on an upward trend, which is a good sign, which is a very good sign, because this is what the trend suggests. So though a lot of statistics like the MAPE and such things are not as good as the expert modeler feature, but when you examine the blue line, it is climbing up, which is consistent with the earlier trend. I would like to show you the plot that we obtained for the expert modeler. Please observe, the blue line was almost flat. This is not a good model at all. It is not tracing, it is not learning the pattern adequately. The current trend seems to be an upward one, which is a good sign. So what I'm going to do now is go to the training data. I've got the predicted values, LCL as well as the UCL. Let me right click on all the three columns and copy it. Let me do this again. Right click and copy. I'll be going to the test data. So this is the test data that I have. I'm going to right click and say paste. So you can see here, there are three new columns which I'm pasting against the test data. So this is the predicted value. We have the LCL as well as the UCL value. So we have the actual price of rice versus the predictions for rice. How do we compare these three columns? Let's now go to the analyze menu. Come to the forecasting option. Here, there is what is called as sequence charts option. Here we have what is called as the sequence charts option. Let me click on this option. The earlier prediction, I'm going to kick this out because this is the expert modeler prediction. I am going to look at the prediction that we have specified as 113. Let's examine the actual versus the predictions obtained by the new model. The rest of the things will remain as it is. Let me click on OK. This is the output window. I'll have to look at the, sorry, this is the date. What you saw earlier was the data window, and this is the output window. What is really interesting here is, please observe that you have the blue line which represents the actual data, and then you have the red line which represents the predicted data. From January 2001 to May 2009, you can see here the red line more or less is tracing the path. I'm saying more or less. There is some kind of a gap that you observe from September 2007. But I'm not interested in what has happened before May 2009. We are interested in what will happen post May 2009. And when you look at post May 2009, when you compare the blue line with the red line, the blue line and the red line are very, very close to each other. The blue line is climbing up and the red line is also climbing up. In fact, for March, I think the predictions are very, very accurate. For March 2010, the predictions are accurate. So this is what a customized model can do. Because you're customizing, the out-of-time validation will look a lot better than the expert modeler feature. So this is our current model. Please observe and compare this with the old model prediction. The blue line was the actual data and the red line was the predicted data. There is no match at all between the actual versus the predicted. The new model that we have built, that is ARIMA 113, is looking a lot better. So when it comes to implementation purpose and such things, it is better that we implement this particular model rather than the old model. Now, there's one additional thing which I'd like to do. That is, I can click on this particular option, which is called as the dialog recall option. Here you have the sequence chart. I have rise. This is the actual data. This prediction represents the ARIMA 113 prediction. Let me also include the earlier expert modeler prediction. So we can compare actual versus the two models that we have built. If you click on OK, so this is how the lines will look like. The blue line is the actual, green line is horizontal, bad prediction. The red line at least is tracing the path. There is some gap here, which is a slight bit of a worry, but this is how the predictions will be. You can't expect 100% accurate prediction. There's one more way in which we can examine, which is make sure that the actual data will lie within the predicted class intervals. If the actual line is lying within the class intervals, then again, you can take a lot of comfort in the quality of predictions. So again, let me go back to the dialog recall, choose sequence chart. Let me remove both the predictions here. I'll just be using LCL and UCL here. I want the actual values of rise post 2009 to lie within the interval of LCL and UCL. Now let me click on the OK button. So this is how the data appears. Please observe the blue line, because the blue line actually represents the true value or the actual data. You can see here, this is the blue line. There's a portion of the blue line which is outside the LCL and the UCL. LCL stands for lower confidence limit and UCL stands for upper confidence limit. This is the green line which represents the LCL. The red line represents the UCL. Ideally speaking, the blue line, which is the actual line, should lie within the expected confidence limits. There is one portion of the blue line which is outside the range, which means that the predicted values are good, but not good enough. There is further scope for improvement in the predictions that we have made. Yes, you can technically argue that after let's say 3 months of May 2009, the blue line is coming within the green line and the red line, which is a good sign, because the actual value should always lie within the predicted intervals. But this is a slight bit of a concern that a small part of the blue line is lying outside the range. How do we improve upon the quality of this prediction? Are there better ways in which we can build this model? That's the topic which we are going to examine in the coming videos. I thank you very much for watching this particular video. In this video, we have seen the performance of the expert modeler. We have looked at a lot of fit statistics. We have built two different models. One is expert modeler. Second one is a customized model, ARIMA 113. Though expert modeler was good, we found that the customized model, ARIMA 113, outperforms the expert modeler when it comes to out-of-time validation. I request you to subscribe to my channel, also like and share my videos. Thank you very much for watching this particular video. Have a great day ahead.